Okay, so in the second problem, we're given the joint density function of x and y is like this: a over x y squared, and we're given an area where such expression holds, like that. Y it's bigger than 1, larger than 1, and x is between 1 over y and y, and in the first question, I think the first question is very important. It's essential to solving all the subsequent questions. We need to draw the region where xy is non-zero. Well, in order to do that, we just draw the region where we need to depict in the Descartes coordinates where y minus 1, x between 1 over y and y is. Well, we're going to take a look at the conditions one by one. First, when y minus 1, we just draw like my y equals 1, and 1 minus it's the upper area, and when x is between the y 1 over y and y, it's not so easy to find at first glance. We're gonna take it into two consecutive equalities, two separate equalities. So first we know that it's smaller than x and x smaller than y. Well, it's very important because we know that y is larger than 1. So x is larger than 1 over y. So we can know that x is positive. Both x and y are positive. So we only need to discuss the first part of our Descartes coordinates. Which means x is also positive. We don't need to discuss the situation when x is negative. So we need to know where this area is. Judging on that, we could just simply multiply both sides by y. So we get x1 is larger than 1. Well, when xy equals 1, we know obviously this is a hyperbola. So we could draw this. It will be depicted like this. This is a hyperbola. And when xy is larger than 1, we know that the more right, the larger the constant of the hyperbola is. So when x is larger than 1, we means that area. So we could actually mean that area. Okay. So we have two areas and intersection. The third one, x is smaller than y. So we could simply draw the curve when y is x. Well, it's gonna be like this. Well, x equals x. Obviously, when the upper part of this curve, the upper area of this divided by the curve, upper part of the curve, it stands for the area when y is larger than x. X is smaller than y. So we have that. Okay. Oh well. Take a look at this intersection. This is actually 1, 1. I actually did some calculation, and after some easy calculation, we could see that when x minus y is equal to 1 and y is also equal to 1, actually satisfy the the 1, 1 point. It's located on all of the three curves: the hyperbola, the horizontal point, and also the oblique straight line. So actually, I did do some calculations on it, and okay, we need to find out the common area of all these three that could satisfy all three equalities. So with the help of these arrows, we could see it will be like this. So we completed our first question. It's just a shaded area. We have a check, right? It's like that.